Okay, so before getting into this worksheet, I do want to just address a few things. If you notice over here, we do have what looks to be Newton's second law of motion, which is force is equal to mass times acceleration. And then you actually have this symbol over here. This is a summation symbol. What we're going to be doing later on is figuring out, we're going to have the summation of the forces acting in a certain direction is equal to mass times the acceleration acting in a certain direction. So we'll deal with this later. Don't worry about that just yet. What I want to do though is kind of come on over here and look at our two friction formulas. I didn't really discuss this just yet, but if you're thinking about friction acting on an object, what are the components that you're actually kind of thinking that might influence that amount of friction in between those two objects? Well, maybe you're saying to yourself, if the object weighs a lot, if it's very heavy, then there's going to be a lot of friction. Well, yeah, okay, so in a lot of contexts where the weight is going to be equal to the normal force, if you're dealing with a flat surface, it's going to be a little bit different when we're going to be dealing with an inclined plane, which is the reason why we're not saying the weight of the object, the force due to gravity, but instead we're actually going to be referring to the normal force. And what's another component that actually will influence how much friction there is between two objects, or an object and a surface? Well, it's going to deal with the what is the surface? What is the object? If you have a hockey puck and an ice skating rink, and you're to think about the friction between those two objects as the hockey puck is moving across the ice, that's going to have a little bit of friction involved there, right? Very little. Versus if we're to deal with a rubber object across concrete or so, then the friction will actually be a lot greater, and that actually has to do with the coefficient of friction. The value of the coefficient of friction will always be between 0 and 1. Just keep that in mind. If it's impossible to actually have it be outside of this range. And the very last thing I do want to actually have you recall on is the definition of acceleration. Keep in mind that the acceleration is a change in velocity over a certain amount of time. Let's say this. If an object is at rest, what's the acceleration? Well, it's not moving at all, right? So if it's not moving at all, how could it have any sort of acceleration? What's the value of an acceleration? It's going to be 0. Or let's say this. Say if the velocity is not changing, if we have an object that's moving across like this, we would actually say that the velocity is not changing, that the velocity is constant. If the velocity is constant, what is the value of the acceleration? Would you say that this object is accelerating at all? Well, I wouldn't say so. I would actually say that it's got 0 acceleration. So that's exactly it. So if an object is at rest, or if it's not changing its velocity, if it has a constant velocity, then the acceleration is 0.